So overall, we're looking to create a mechanism that will fit inside of an impact gun that's already made. And what we're looking for that mechanism to do is to control the airflow that passes through the impact gun. That way the output torque can be adjusted based on a predetermined target. And we're looking for this mechanism to have a tolerance of plus or minus 5 foot-pounds from what we initially set it to. And so our problem statement, the current torquing procedure, it's actually it requires the handheld torque wrench, and so you have to go after you bolt on the wheel to the car or truck, and you have to manually push down until it clicks or until you're alerted that you reach that torque output. And so it's an extra step in the process of bolting on a wheel to a vehicle, and so we're looking to eliminate it by having the torque put on upon the initial assembly of the wheel to the vehicle. So who needs what, because why? Companies that operate in a fast-paced work environment, they are always looking for ways to improve their efficiency. And so we believe that this method of ensuring the torque being applied to an assembly can be beneficial to them, as their customers can be more delighted by receiving their work in a faster time. And so as I said earlier, it's time consuming that you have to go through with the manual torque wrench after you bolt onto an assembly. And so the target users for us, we're mainly looking at companies like Discount Tire, NTB, or Brake Check, as they are always bolting on and unbolting wheels during their services on vehicles. And so, like I said earlier, that it can be a faster process, cut down service time.
Why did we choose this project? Well, me, Cordell, and Giancarlo, we both work at a Discount Tire shop. So we decided that we had a problem that we could possibly fix, which is torquing lug nuts by hand. So if we could make our impact guns a reliable torquing mechanism, and we can adjust what the output is, then that would take a step out of our daily process of bolting and unbolting wheels, and would cut down on our time to work on vehicles every day. And it would make our job more efficient. It would cut down on our work time and take less manpower to do the same job each day. So our background in the business kind of brings insight to this, and what we would need the impact gun to do and how well we would need it to work, because safety is a big priority in our line of work. So the background for the design, we were looking at a lot of different things that control airflow. One is air conditioning ducts and vents, how you can open and close them. Another one that really got the design going is the air compressor controllers that can adjust how much air is coming out of an air compressor when you turn it on. So you can twist and untwist a screw, which controls a valve that lets a certain amount of air out, and it'll tell you on the gauge how much is coming out. And these two components are really what got our design going, got our idea flowing in the right direction. So how do they work again? They regulate air pressure through an orifice. This picture right here is kind of where we want to go, and where we're trying to go right now with our design and our testing. A spring controls a little mechanism that opens and closes a small area, and depending on how big the area is, determines how much air goes through it and how much air is the output versus how much air is going in.
For our design, again, we're trying to implement it inside the gun. We're taking currently existing designs that are in line with the hose and just rearranging that to be able to fit into the gun casing itself. The controlled orifice, we would have a knob on the outside of the gun that allows the orifice to be changed. The knob would be marked, so the user could just turn it to a specific torque, and then the orifice would be at the correct setting to allow that torque to go through. And then the gun itself would not tighten the nut past the torque that it was set to. As far as differences, our design is going to be using, we won't have a gauge on the design because the gauge shows air pressure, and we don't really need air pressure to be shown for the user. What the user needs to know is the output torque because that's what they're looking to modify. And then again, the torque is going to be based off of the air pressure that's let through the orifice. So it's our job to figure out how to change the orifice. We're still trying to pick the correct orifice shape and figure out how to get that to correlate to specific torque values. Oh, I added this one. So as far as testing, before we actually pursue a specific model, we're going to be running simulations. We picked a testing software. It's an Autodesk software titled CFD. And basically we can design our multiple orifice shapes and sizes in Inventor, move those over to CFD, and then we can run simulations and read output air velocity and pressure based on different input settings, as well as alter the opening size of the orifice. So it will help us to calculate exactly how much torque we're going to be getting for each orifice opening based on the degrees of the orifice. And then we can compare the models. So we have different models, and we can compare those different models to figure out which one's the most preferred based on the control of the airflow. A lot of the orifices are more on-off type orifices. So whenever you start to open it, there's just a very small gap that will allow control before you reach your full airflow. So we need to pick an orifice that allows us to change the gap for greater control, as well as we can analyze size and complexity.
So problems we've had along the way, a big one that's affected where we've gone with our design and how we're testing and how we're basing all of our results off of is pressure varies whenever you have a big system of guns and pressure lines that are all connected out of just one or two compressors. So we're going to take a perfect scenario and base everything off of that, because if you had just one hose hooked up to one compressor with just one gun, you'd have pretty much a perfect scenario. So that's what we're going to base it off of. And then finding a proper software to test our airflow. We had one before. Turns out it doesn't work or do exactly what we needed it to do. So that took some time away as we were trying to get that set up. We did find a new one though, and we're getting all of our designs transferred over into it right now. Deciding on proper materials for use. That's still in the works. And then the amount of materials needed. Knowing which design would be best since testing is limited. This problem should be solved with the new software that we found, but that has been a problem we've been dealing with. And then finding time to work together on the project, since all of us have been fairly busy, but we're solving this problem too. So solutions with the varying air pressure, like I said, we're going to go to a perfect scenario of 150 psi entering the gun 100% of the time. This may not be feasible in a large workplace, but can be with one gun on a single compressor, and monitors can also be put in place to alert variance of pressure in the line between the gun and compressor if those were needed. The software, like I said, we just found one, and we're going to be implementing that new software, as opposed to we were going to do a bunch of manual testing, but this new software should fix that. Material selection, we have some materials picked out. It's not set in stone yet. And then deciding on best design. A lot of the control valves for air compressors work similar to this. There's a spring connected to a screw, and as you screw in that screw, the spring compresses this piece of metal that's on an orifice, which lets it grow and shrink, allowing more or less air through it. So that's probably what we're going to be going with. And then there's some other designs that instead of a piece of metal going up and down, it's a circle opening and closing. And then finding time to work together. We are changing our schedules and able to work together more often than we were at first. It was an unforeseen hurdle that we had to get through, but everything's constantly being modified so we can get it done. There you go. And then the product outcome is we want to have a impact gun with a dial on the side, and this dial is going to have torque settings on it, and you can adjust the dial to whatever torque setting you need to be. And that's it. And I sent that to you.
Yeah, please send it.
Katie.